Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many 5-digit zip codes are possible if the digits can be repeated? This type of question can be answered by the fundamental counting principle, which allows us to multiply the possibilities for each of the situation. Here, this situation is not in the Philippine setting, because in the Philippine setting, our zip codes, or we have a 4-digit zip codes. We're just coming up with this kind of situation, so this could be applicable for all types of situations. So we have here a 5-digit zip code. That would mean we have here the first, second digit, third digit, fourth digit, and a fifth digit. And since there's no restriction here, we are told that the digits can be repeated. That would mean that for the first placement, we can apply here, or we can use 0, 1, 2, 3, 4, 5, 6, 7, 8 until 9. That would mean there are 10 possible digits that can be placed here, because zip codes are represented by numeric codes. Okay, but they are actually, if you talk about the types of data, they're actually nominal data, but we are using numeric for these types of codes. For the second placement, since digits can be repeated, we could also use 10, because we have 0 until 9 as well. And this is also true for the third, fourth, and fifth digits. Now, the fundamental counting principle allows us to place here the number of possibilities. Again, we have here 10. For the second, we have 10. As there are no restrictions, we also have here 10, 10, and 10 possibilities here from 0 to 9. As mentioned, this type of problem is not a representation of any a nation or type of geographic origin. This is just for representation, so that we could apply this understanding for all. Now, we are not sure if 0 is not allowed for the first, the second, or etc., because we are just assured that digits can be repeated. For the fundamental counting principle, we simply try to multiply n times m times p times q times r ways. That would mean we simply multiply the number of ways or possibilities for each placement. So if we're going to multiply this, we will get here 10 times 10, that's 100, times 10, 1000, times 10, 10,000, and times 10, 100,000. That would mean for this type of problem, there are 100,000 possible zip codes for a 5-digit zip code where the digits can be repeated. So this is the answer for this situation. And that's Count It In. Talking about getting the luck of the draw. For all in, subscribe now.